Hey folks, I had a question for number 29 out of section 7.4, and I want to preface this with this particular question is a beast. Okay, so a couple things are happening, and I'm going to highlight some of the unique stuff. This x squared is going to be tricky, and this 2 is going to be tricky. So let's start with the idea of the x squared. You might think that's a quadratic factor. And I would get why. Like, I understand why people think that. But if you think about x squared, if I were to make it with a binomial in parentheses, this would be x minus 0 squared. And when you look inside those parentheses, that is a linear factor because it's just x, but it's a linear repeated factor. So if we don't see this as linear repeated, we might not have the correct numerator when we're going through making our fractions, our partial fraction decomp. The other issue that pops up, like I said, is this lead coefficient of 2. And to make my life easier, I want the denominator to have a lead coefficient of 1. So what I'm going to do is I'm going to divide every term in my numerator by 2. I'm going to distribute that division by 2, or that multiplication of 1/2. So 54 divided by 2, you're going to see a 27 here, right? 127 divided by 2. It does introduce a decimal, but I'm okay with that, right? Then 80 divided by 2 is 40, and 16 divided by 2 is 8. So that's a couple of the things I have to deal with. Now, taking a look at this other factor here, this is also linear, but its exponent is 2, so it's also linear repeated. So when I try and do the partial fraction decomp, you can see linear factor repeated with x and then x squared, and then linear factor and repeated with 3x plus 2, and then 3x plus 2 squared. At this point, I'm going to multiply everything by the LCD, which is going to be x squared times 3x plus 2 squared. I'm going to multiply that LCD to this beast, this beast, this beast, this beast, and have myself a canceling party. And you can see that canceling party start to happen. Once you do all of the canceling, and some of the canceling is easier than the others. I think this one tends to not give folks trouble, right? And then the other ones might. So if we look at this canceling party, one of the x's cancels one of these here, but that leaves me with an x and a 3x plus 2 squared. Here, nice enough on the b's, the x squareds just cancel, and it leaves me with b times 3x plus 2 squared. For the c, right, one of the 3x plus 2's cancel, and it leaves me with c times x squared times 3x plus 2. And then last but not least, the squareds cancel here, and I'm left with d and x squared, right? And so that's what you see. I'm going to go ahead and put a box around this. That's what you see with that formula or that equation there. And at this point, if you want to solve for A, B, C, and D, you can substitute in values, which is what I'm going to do, or you can FOIL everything out, distribute everything out, and line up cubic terms to what will eventually be cubic terms, so on and so forth. I'm going to do the substitution method. I think that's going to be simpler, not necessarily easy, but simpler. All right, and let me clear out my work for right now and just start talking strategy. When I think about letter or numbers I want to sub in for x, I want to see what would zero out x. Oh gosh, sorry, someone's at my door. I'm in my office. Someone was just knocking. They're going to go away. Not in a bad way, it was a friend. And then for this particular factor, if I want to see what x value to put in, I'm going to let 3x plus 2 equals 0. I'm going to subtract 2 from both sides, and then divide by 3. So it looks like the two x values I'm going to sub in are going to be 0 and negative 2/3, because it's going to knock out a lot of my factors. But because these are repeated, right, because I have x squared and 3x plus 2 squared, right, those are both linear repeated, I don't have any other x values to plug in that would knock anything out, that would zero anything out. And I don't know what I did. I'll put a little arrow. I haven't scrolled down in a minute. I don't know what x values I plugged in, but ones I like to plug in after I run out of strategic x values, I'll probably plug in x equaling 1 and x equaling negative 1. I'm going to put a question mark because I don't know until I scroll my iPad down, but we'll see. All right, so let's start by letting x equal 0 and see what we get, okay? And I'm going to erase all of this so that we can see what's going on. Okay, So if x is 0, this on the left side, 0, 0, 0, 8 is going to survive. So that's where you see this 8 popping in here. And if x is 0, this is going to go to 0, that factor, right? B times 3x plus 2 is not going to 0 out, but x squared will 0 out, and again, x squared will 0 out. And if x is 3, this is going to be 3 times 0 plus 2 squared. 3 times 0 is 0, 2 squared is 4, so this is ultimately going to be 4b. And when I divide both sides by 4, I'm going to get b equaling 2. So at some point, I'm going to put a 2 over there, okay? And like I said, the next thing strategically I'm going to do, let me erase what we did just now. The next thing I'm going to do is I'm going to plug in negative 2/3. All right, and you can see me doing that, well, here. But I want you to hear, like, when I plug in negative 2/3 to the left side of this equation, I absolutely used my calculator. And you get a nice fraction when you do that. But that's how I got it. I plugged this. I'm going to just put plugged into my calculator. I did not want to crunch that by hand. So when I plugged that into my calculator and I used all those correct parentheses, I got 14 over 9. Now, if I'm plugging in x equaling negative 2/3, this factor is going to 0 out, this factor is going to 0 out, this factor is going to 0 out. This is the only one that survives. So if I think about d times negative 2/3 squared, that's like saying d times negative 2/3 times negative 2/3. Multiply those numerators, I'm going to get d times 4. Multiply those denominators, then I'm going to get 9 on the denominator. And that's where you see me getting 4/9 d. If I want to get rid of those fractions, I can multiply everything by 9. Right? Those will cancel, and then ultimately I divide everything by 4, solve for d, and d is 7/2, right? So now I've got 2 of my 3 numbers. All right, so we know b is 2, and let me scroll back up. If d is 7/2, I'm ultimately going to put a 7 here and a 2 down here. But I still need to find a and c. And I initially guessed that I would either plug in 1 or negative 1. Let's scroll down and see what I did. All right, there's the first one. Yep, 1 and negative 1. That's a pretty common substitution I do. So when I plug 1 into the left side, I get 277 over 2. When I plug 1 into the right side, and you see me subbing in 1 for x the whole way through, I get this, right? 25a plus 25b plus 5c plus d. Well, I know what b is. We found that to be 2. We know what d is. We found that to be 7/2. So when I plug those in and subtract those numbers over here, this is ultimately what I'm winding up with. I have an equation, 25a plus 5c. Okay, I'll just put that in my pocket for now. I'm going to repeat that entire substitution, except now I'm going to let x equal negative 1. When I plug all of that in, right, and then I simplify, and I get this equation, and I plug in 7/2 for d and 2 for b, and I get this equation of negative 1 equaling negative a minus c. Although I decided as I went from here, I just multiplied everything by negative 1 because I didn't want to deal with the negative numbers or the negative signs. Then all of a sudden I have a system, a 2x2 system of equations. All right, and then at that point, you can use substitution, you can use elimination. If I'm looking at this, I might opt to eliminate the c's. If I did that, I would multiply this equation by negative 5. And as I scroll down, that is what I did. So when I multiply that by negative 5 and add both sides, right, the c's cancel out. I get 20a equaling 80, or a is 4. And then I can sub that back in. I think I subbed it back into this equation just because it was the simplest one. So if a plus c is 1 and a is 4, then c is going to be negative 3, right? So then you see me ultimately writing my answer up here, right? There's a, b, c. I put the negative sign here, negative 3, and then d was 7. Don't forget that 2 down there. All right, thanks so much. Bye.